Hello everybody again. Next we have a demo of a fantastic dApp running end-to-end from the Internet computer that helps you manage ICP governance tokens and interact with the network nervous system. The network nervous system is a completely open, tokenized governance system that runs within the protocols of the Internet computer blockchain. The network and the node machines run by independent parties that host the network run under the control of the network nervous system, which is incredibly exciting because it makes the Internet computer the world's first fully adaptive blockchain. Through the network nervous system, the Internet computer can evolve and adapt in real time. By leaning on the chain key technology used in the lower layers of the network, it can roll out protocol upgrades to node machines, create new subnet blockchains by combining nodes to increase network capacity, tweak economic parameters, configure cryptography, and perform many other tasks, all without interrupting the network's operation or breaking security. This contrasts with traditional blockchain networks, which can only be updated in meaningful ways by persuading participants to cooperate in highly disruptive and sometimes divisive hard forks. After Genesis unlock, the network nervous system will begin to exert the will of the community, mediated through algorithms, by processing large numbers of proposals every day and executing adopted proposals entirely automatically. You can participate by staking ICP to create new voting neurons, which earn voting rewards, which can be configured to vote automatically by following other neurons in a system of liquid democracy. In the next few weeks, we expect many thousands of you will create neurons, greatly adding to the security of the network. Let's head over to our Zurich office to take a look at the dApp that provides an easy way to interact with ICP and network nervous system neurons, where we'll find David Millar-Durrant, one of the great engineers working on the project, with Gilbert Jolly in the background, joining from Spain. David, hi, over to you.
Thanks a lot, Dom, and thank you very much for the introduction. I'm going to jump right into it. This app lets you do everything you want to do with the NNS, with ICP, and with sort of canisters and cycles. When you land in the ICP tab. The ICP is the key to all of this. So as you can see, inside my account, I have 100 ICP. Now, each account has a number of sub-accounts. So you sort of have pots where you can segment your money into different addresses. Your address is here. If you want someone to send you money, you send them this address and they send you the ICP. So I'm going to create an account name. I'm going to call this my holiday fund because I'm sure people would love to donate to my holiday fund. Okay, so I've got this address here. Just so I can show both sides of the payment system, I'm going to make the payment myself. So you go from this account, you create a new transaction, which is to send to an account. Now, these are accounts I've already made payments to or I sort of own. So I can see there's an account called Holiday Fund. I'm going to send something there. I'm going to say, put 10 ICP in my Holiday Fund. I think that's sort of a nice down payment to get started. Review the transaction, from, to, confirm and send. And that's just that easy. Each transaction takes a couple of seconds, goes through a full consensus on the NNS subnet, and at the end, you get this out. As you can see, I've got 10 ICP in the holiday fund, and I spent just over 10 ICP because you need to include a small transaction fee. So I want to get involved in the voting system in the NNS. How do I do it? First thing you do is you stake a neuron. So you go in, you create a new type of transaction, which is the stake. So I want to stake 30 ICP because that sort of seems like a good amount. Stake 30. Now here we're sort of creating the initial neuron. And in the next step, you get to decide how long you want to lock it up for. Now the lockup is basically the minimum amount of time it could take before you can dissolve it again. The higher the lockup period, the more rewards you get each time you vote. So I'm going to lock mine up for just under 2 years. That seems like sort of a good amount of time. And as you can see, this gives me a higher voting power than the number of ICP I staked. So I'm going to update the delay. Now, this is sort of a big commitment here to the internet computer, because I'm saying I'm not going to take my money out of it for the next nearly 2 years. And yeah, I'm sure I want to do that.
I'll just reiterate that you can always increase the dissolve delay of your neuron up to 8 years, but you can only decrease the dissolve delay by dissolving it, which takes place over time. So if you've increased your dissolve delay to 8 years to maximize your voting power and voting rewards, it would take 8 years from the moment you start dissolving it to recover the ICP staked inside.
Yeah. And the reason we do that is we try and get people to have an investment in the long-term value of the internet computer if they get to decide about votes that may influence that future. So we use a form of liquid democracy here at Dfinity, which is that you can follow other neurons. So you may not want to actually actively vote in everything. You may just want to pick people you trust to do the voting for you on certain topics. So in this case, I don't really want to vote on governance things. So I'm going to find someone to follow who I will follow automatically, but I can always vote against them if I feel like it. In this case, I'm going to follow the Internet Computer Association because they're sort of a lovely group of guys. And this means that whenever they vote on something, I vote with them, and also I get a voting reward. Now, you can follow multiple people and only vote with them if they all vote in the same way. And you can also manually enter a followee and by selecting them by neuron ID.
You can configure your neuron to follow any number of other neurons on a particular topic, and it will follow a majority of the followees. So for example, if you follow the Internet Computer Association and the Dfinity Foundation, then both the Internet Computer Association and the Dfinity Foundation will have to vote the same way for your neuron to follow, because it follows a majority of the votes. Something else worth mentioning at this juncture, the Dfinity Foundation neuron and the Internet Computer Association neuron aren't actually controlled directly by the organizations involved. They're special kinds of neurons that are controlled by their own followees. So in actual fact, for example, with the Dfinity Foundation, you're looking at like 20 plus team members being followed, and it's actually those team members who are able to add and remove new followees to the Dfinity Foundation neuron.
Yeah, that's exactly right. And this is how you add multiple followers, and you can add extra followees if you feel like it. And this sort of allows them to vote between themselves and to decide the sensible thing to do in each issue. And you can pick different followees for each class of vote. So in this case, network economics, changing sort of the fundamental cost of things on the network. Governance is sort of big decisions about the network. And there's all sorts, we've got about half a dozen of these things. Okay, so let's go through what you can configure about your neuron. So this is a neuron ID. This is what you give people if you want them to follow you. Here is the amount you have staked. Here is the period of time it's locked. So this is sort of how long until you can get your money out. So if you press start unlock, that number will gradually decrease down to 0 until eventually you can get your money out.
Once you've started dissolving neuron, it'll count down day by day until you can disperse the ICP that's locked inside. But there's no way of accelerating that. Once you've increased the dissolve delay, the only way you can reduce it is by starting the unlock process, and it's going to dissolve day by day.
Exactly. So if I started unlocking today, in just under 2 years, I'd be able to get my money out. So next up is maturity. Whenever you vote on a proposal, up to 3 days after that, you will receive maturity. Once this maturity is sufficiently large, you're able to spawn a new neuron. And that neuron is created with brand new tokens minted by the network, which reward you for taking place in the governance system.
Every day, the network nervous system has a sort of pot of rewards that it wants to distribute to neuron holders. And that pot of rewards is calculated according to a completely different set of rules. And it divides that pot of rewards amongst neurons that participated in voting according to their relative voting power. And so, of course, many of us, me included, are thinking, well, how are we going to manage our ICP? And certainly in my case, I'll be locking up a bunch of my ICP in 8-year neurons.
Yeah, exactly right. And if you lock up your IC for 8 years, you get the maximum voting power and the maximum voting reward through maturity. So going down below, you can choose who you follow at any point and change that whenever you like, as you see fit. So let's go look at some proposals. So because we haven't yet reached token liquidity, this is running on a testnet. So normally you'd see a very large number of proposals going by. There'd be sort of diverse, all sorts of weird and wonderful things that members of the community feel like should be happening on the network. But right now we only have the one.
You know, the network nervous system completely controls and manages the network, not just the individual devices that host the network, but the overall network configuration that exists, if you like, between the devices in cyberspace. And there's a very broad range of different proposals that this network nervous system can process, all of which get executed automatically. And so you're looking at a proposal here that would modify the cost of memory provided by the internet computer to smart contracts. And this is a really, fundamental aspect of this whole kind of system, that even these sort of super detailed parameters that the network uses can be configured through proposals. And we expect there to be, many hundreds of proposals going through the system a week. And most users, of course, won't want to vote on them all individually. They'll probably choose a subset of proposals that they want to vote on manually. And for the rest, they're just going to configure their neurons to vote entirely automatically by following other neurons.
So you can only vote on proposals that were created after you had created your neuron. And that stops people sort of getting a big bunch of ICT, flooding into neurons, and then deciding on a proposal very, very quickly. So this is the voting page. So here you can select the topics that you're interested in. So some of these are more interesting than others and more exciting than others. You can look at the reward status, so sort of whether or not you actually make money out of it, whether or not these proposals have been executed, adopted, or failed, sort of just generally browse them. So here's an open proposal. Reflect falling hardware prices, reduce smart contract memory costs by 5%. Now, while the value of cycles is fixed, the value of computation is always falling. So occasionally you're going to see proposals that look like this on the main network. In this case, we think the cost of memory has gone down practically by 5%, so we want to decrease the cost.
When you think about it, this is just incredible. When or if this proposal gets executed, the network nervous system will change an economic parameter, the memory cost parameter, right the way across all the subnet blockchains in a manner that occurs within the protocol. So this is a blockchain that can not only update itself, but configure itself in real time. And we're going to see hundreds of proposals going through every week. Of course, most users won't want to vote on hundreds of proposals, and they configure their neurons to vote automatically by following other neurons. But this is an example of a really impactful proposal that can be submitted.
So right up here, we've got the title, and here someone's given attached a URL where you sort of go into why this is a sensible proposal. You can't just sort of say, this is right because I say it's right. You've got to really make a good argument for it. We have the proposer. We can look at sort of their history and work out what kind of a voter they are. The topic, network economics, and here's sort of some relatively unstructured data on what the proposal actually does. I'm going to cast my vote. I have 37.13 votes because I get the voting bonus for staking my neuron for a long period of time. Here, if I had multiple neurons, I could select some of them to vote, but in this case, I only have the one, so I'm going to select that to vote. And I'm going to vote to adopt because this is a relatively sensible proposal. Once you've voted for a proposal, you can't take that vote back, but I'm pretty sure it's a good idea, so I'm going to say yes.
And boom, just like that, you've added your votes to a proposal, and when a majority of the voting power either votes to adopt or reject, the internet computer's network nervous system decides. If the majority has decided to adopt, that proposal will be automatically executed right the way across the network.
And as you can see, shortly after I voted, one of my very, very large followers decided to vote with me, and the proposal has been accepted overwhelmingly. That's just how easy it is to get involved in the decision-making process of the internet computer. Going back, so we've done ICP, we've done neurons, we've done voting. The last thing is, how are you going to create smart contracts on the internet computer? Next thing we want to do is we want to deploy a canister to the internet computer. Canisters are what we call our smart contracts, and they are how everything runs on the internet computer. And I want to get involved. I want to make some software. So what I'm going to do is I'm going to create a canister. Create a new one. The canister name, I'm going to call it my website, because I'd quite like to host my website on the internet computer. Confirm the name. I'm going to pick where I get my ICP from. In this case, I don't want to take it from the holiday fund, much rather put it in my sort of base account. I'm going to put in 0.1 ICP, charge it up, because 42 trillion cycles is an awful lot of cycles, and that thing will run for quite a long time off the back of that. So this is, if anything, I'm overcharging the thing. I'm going to review the cycles process, double check everything.
And this is really cool. So, and by the way, it's not just creating new canisters that are pre-charged with cycles, which of course are fuel for computation, but you can also use the same system to send cycles to pre-existing canisters. And those cycles, of course, are very commonly used to power computation, but they also, because they're constant value, they can also be used in systems like DeFi. So yeah, potentially you'd use the same mechanism to send out cycles to DeFi systems, or even just a wallet you're using for payments.
It's just that easy to get a smart contract that is owned by you running on the internet computer. And the next thing you'd want to do is you want to change the controller, go into DFX, and just get started building a great developer experience. That's everything on the network nervous system.
David, thank you so much for this. I think this DApp is going to provide a really great way for people to get involved with the network nervous system. And we expect billions of dollars of value to be staked as neurons in the network nervous system, which will not only make governance incredibly secure, but we believe will ensure that proposals are adopted in a manner that drives the success of the Internet Computer Network, the world's first fully adaptive blockchain. All right, thanks.
Thanks.